أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله والصلاة والسلام على رسول الله. We give thanks to Almighty Allah, the cherisher and the sustainer of the universe, the one who taught men by pen. We ask Allah subhanahu wa ta'ala to bless the soul of our Prophet Muhammad bin Abdullah sallallahu alaihi wasallam, his household, his companions, and the generality of Muslim Ummah till the day of accountability. Ameen. This is another topic in the series of our topics in third term scheme of work at CTY Model College, Ibadan, State, Nigeria. This is chemistry for SS2, week 6, lesson 1 and 2, as presented by Mr. Ojakunle Ridwan and Mr. Abdulatif Mansour. The topic is chlorine and its compounds. This is the first part of the broader topic, chlorine and its compound, for this week 6. We shall have it also at week 7, the other aspect of the chlorine and its compounds. This is the first lesson of this first part of chlorine and its compounds. I want to talk about discovery and occurrence. Chlorine, it is the most important element of a family of very reactive nonmetals known as halogens. This important gas was discovered by Chm2 in 1774 when he heated some concentrated hydrochloric acid with manganese 4 oxide. It was later in 1810 that Davy, another scientist, named it as chlorine due to its greenish yellow color. The name chloro actually came from the Greek word meaning greenish yellow. It should be noted that each member of this family of halogen, including chlorine, has 7 electrons in its outermost shell. So that means each of them needs 1 electron to complete its octet structure, the octet electronic configuration. Hence, we say that their valency is 1. How do we prepare this gas on a small scale, small quantity of it? That takes us to laboratory preparation of chlorine. If we want to prepare this gas in the laboratory, it is usually prepared by the oxidation of concentrated hydrochloric acid with a strong oxidizing agent such as manganese 4 oxide, potassium tetraoxomanganate 7, or lead 4 oxide. These are the reactions, the equations of the reactions showing what we have just said now. Manganese 4 oxide plus 4 HCl, when it is heated, we are going to have manganese 2 chloride, and you are going to have water being formed and chlorine gas will be released. Or if you have sodium chloride heated with manganese 4 oxide and you acidify the whole medium, you are going to have sodium sulfate, manganese sulfate, and with the evolution of chlorine gas. It should be noted that this preparation, that is that number Roman figure 1, using concentrated hydrochloric acid with manganese 4 oxide, this must be prepared, must be carried out in a film cupboard, and only by a teacher, because of the poisonous nature of the gas. When we get to the physical properties, we shall see all this. So looking at this diagram, you have concentrated hydrochloric acid with manganese 4 oxide. When it is heated, so a gas will be released. The gas is then passed through concentrated sulfuric acid, that is concentrated tetrasulfuric acid, just to make sure that the gas is dried. Then it is now collected by upward displacement of air. The chlorine gas goes down, air covers the upper part of the jar. So how do we know when the gas jar is full? So we just test it by the corresponding test kits or test materials. Like if you want to know whether the gas is at the upper part of this jar now, there are ways we test for chlorine. So we help us to know that okay, the gas jar is actually full or is filled with the chlorine gas. Moving forward, apart from that, preparation of chlorine can also be done with concentrated H2SO4, NaCl, and manganese 4 oxide. So this diagram is also giving us the second way. The equation is below here. This is the equation. We have it NaCl plus MnO2, 2H2O, MnO2 plus 2H2SO4, giving us Na2SO4 plus MnSO4 plus 2H2O, and chlorine gas release. So this diagram is actually telling us that. As you can see, a funnel, we have the H2SO4 there, we have the flask, and three of the three reagents are mixed inside the flask. And you have the evolution of the gas being passed over water. If you want to dry it, we pass it over concentrated H2SO4, then we are going to have the chlorine gas being filled inside this gas jar here at the right hand side. Moving forward, we can also get it using a very strong oxidizing agent like MnO4. So as the other equation, the Roman figure 2 here shows how we can prepare chlorine in the laboratory. If you want to have it on a large scale, chlorine is manufactured industrially on a large scale, meaning that industrially, by the electrolysis of brine. That is NaCl is the composition of brine. The ocean water is what we refer to as brine or seawater. So by the electrolysis of the chloride of molten sodium, this sodium chloride, molten magnesium chloride, or molten calcium chloride, all this can be used or as the starting materials in the industrial preparation of chlorine, employing what electrolytic method. The chlorine gas produced is then liquefied and stored under pressure in steel cylinders. As you know that during electrolysis, chlorine will be released as a gas at the anode, where we have oxidation. So loss of electron will happen, and you're going to have release of chlorine gas there. So now, what are the physical properties of this gas we are talking about? 1. Chlorine is a greenish yellow gas with an unpleasant choking smell. It chokes. It is moderately soluble in water. It is about 2.5 times denser than air. It can easily be liquefied under pressure. It is a poisonous gas. That is why we have to perform the experiment of its production in the laboratory in a film cupboard. Film cupboard is a huge cupboard like that, so that it can trap any poisonous gas that is being released when they are being produced, so that they will not affect us as human beings. Chemical properties of chlorine. Chlorine, being a very reactive atom, tries to achieve a stable octet structure in two ways. Either by gaining an electron to form a negative ion, that is chloride ion, or by sharing a pair of electrons in a single covalent bond with itself, forming a chlorine or chlorine gas molecule, or with another atom, as we have in hydrogen chloride gas molecule. So these ways are the important ways by which chlorine employed so that it can react. Now, number 1, with the exception of fluorine, chlorine can displace any of the other halogens from the solutions of their respective salts. For instance, this is chlorine plus sodium bromide. Chlorine gas here would displace bromine from its salts, and you are going to have the product as NaCl plus B, and the bromine will be released in form of gas, or it will be inside the liquid of the reaction medium as bromine liquid. Then chlorine can also displace iodine from its salt, hydrogen iodide, forming HCl, and you are going to have I2, that is an iodine crystal being formed inside the reaction system. Number 2, chlorine combines directly with most other elements to form chlorides. E.g., sodium solid can combine with chlorine gas, forming sodium chloride. That is direct combination. We have iron combining with Cl2, that is chlorine gas, forming FeCl2. It should be noted here that when you have iron reacting with chlorine, now iron is a kind of transition metal that can form more than one chloride of this compound. It can form iron 2 chloride, you can form iron 3 chloride. So it is the higher chloride that will be formed here, not the lower chloride. Why? Because chlorine being a very strong oxidizing agent, so it will prefer to, even if the iron 2 chloride is, it will still be further oxidized to iron 3. So that is why preference is given to the iron 3 chloride when it reacts with, when chlorine gas reacts with iron. Still under direct combination. B, when chlorine reacts with non-metals, so it forms something like this. It can react, that is, with non-metals apart from noble gases, the inert gases, or at times we call them real gases, oxygen, nitrogen, and carbon. All the other non-metals burn in chlorine to produce the corresponding chloride, meaning chlorine can support combustion. H2 plus Cl2 will give us 2HCl. That is hydrogen chloride gas will be formed when hydrogen gas reacts with chlorine gas. This hydrogen gas can then be dissolved to form hydrochloric acid. So when we get there, we'll emphasize more on that. Number 3, chlorine also readily removes hydrogen from its compounds to form hydrogen chloride. So we have C10, H16 plus HCl2. So it will remove it. It will remove the hydrogen and form the carbon. So that is that. Then we have with ammonia, NH3, chlorine will remove the hydrogen from the ammonia, liberating the nitrogen gas, and hydrogen chloride gas will be formed as well. Hydrogen chloride gas can react with ammonia. Hydrogen chloride gas can react with ammonia. So we are going to have what? We are going to have NH4Cl. NH4Cl. Now, moving forward, with hydrogen sulfide, chlorine removes the hydrogen from the sulfide. What do we form? So we form, when chlorine reacts with the sulfide, we have 2HCl plus S. Moving forward, we have water. With water, what happens with water? Cl2 plus, that is a Cl2, chlorine gas plus H2O will give us HCl plus oxochlorate 1 acid. This oxochlorate 1 acid, when it is now in excess, it can be affected by sunlight, so that it can now release HCl and oxygen gas will be formed. So that is what takes us to the effect of sunlight on chlorine water. The diagram here shows the decomposition of chlorine water by sunlight. How do we form chlorine water? When chlorine reacts with H2, we form chlorine water. The first step is HCl will be formed and HOCl. This HOCl will now be further decomposed, and we are going to have oxygen being released, and HCl will be formed there. This is the diagram. Oxygen will be formed at the top part of this place when you have sunlight affecting shining on chlorine water. Now, chlorine as a powerful oxidizing agent, it has the ability to remove hydrogen and its readiness to accept electron from reducing agent to form chloride. Chlorine is a powerful oxidizing agent. Why? Because of its ability to remove hydrogen. We know removal of hydrogen is what? Oxidation. Why addition of oxygen, or when the particular species accepts electron? Such a species that can accept electron will be a very good oxidizing agent. Now, moving forward, chlorine is a common bleaching agent. In the presence of water, it bleaches most dyes and inks except those containing carbon, as we have in printer's ink. Meaning that chlorine bleaches most dyes, but the one that is made by printer's ink is not easily bleached by chlorine. It's a very important point to be noted. This is the equation of how we have chlorine performing its bleaching action. We already know that when chlorine is reacting with water, we form isochlorate 1 acid. As this HOCl now decomposes, it forms HCl and oxygen will be released. The oxygen will now combine with the dye. So and it bleaches off, as we see it colored, and we have colorless here. That is how chlorine performs its bleaching action. Chlorine can react with concentrated solution of NaOH. When chlorine reacts with a cold dilute solution or hot concentrated solution of sodium hydroxide, as shown in the equation below, we are going to have isochlorate 1 acid being formed when it is cold dilute solution. But when it is hot concentrated sodium hydroxide solution, we are going to have sodium triisochlorate 5. If it is cold dilute solution of the sodium hydroxide, we have sodium isochlorate 1 being formed. If it is hot concentrated, we have sodium triisochlorate 5 being formed. It's also another important chemical reaction that can be undergone by chlorine. So it should be noted that bleaching powder is produced by bubbling chlorine through a freshly prepared solution of slaked lime, as we have here, Cl2 plus CaOH bracket 2, so forming bleaching powder, CaOCl2.H2O. How do you test for chlorine? If chlorine is present in a particular gas jar, you can use the first test we call damp litmus paper test. How do you do that? You drop a piece of damp blue litmus paper into a gas jar of the unknown gas. If the litmus paper turns pink and then becomes bleached, so such a gas that is present in the gas jar is the chlorine gas. As we have in this diagram, chlorine bleaches damp blue litmus paper. If you have the chlorine inside this test tube, you put a blue litmus paper there. First and foremost, the blue will turn red, then the red will now turn white. It becomes bleached. That such a gas will be a chlorine if you have such a positive test there. Now you can also use starch iodide paper. Drop a piece of damp starch iodide paper into the unknown gas. If the paper turns dark blue, then the gas is chlorine. If otherwise, it is not. So having a starch iodide paper being put into an unknown gas, and you have the gas turning such a paper into dark blue, so that gas is the chlorine gas. What do you use chlorine to do? Chlorine gas. Uses of chlorine. Number 1, chlorine is a powerful germicide because of its oxidizing nature. It is used as a bleaching agent for cotton, lining, and wood pulp. Chlorine is used in the manufacture of important chemicals like hydrochloric acid, potassium triisochlorate 5 in matches and fireworks, sodium triisochlorate 5 as a weed killer for controlling weeds, bleaching agent, as we have seen above, domestic antiseptic. Chlorine can be used there as organic solvent when it comes to preparing important solvents like trichloromethane, tetrachloromethane. So chlorine is an important reagent in the preparation or production of these important organic solvents. So inshallah, we have been able to look at chlorine, its discovery. We have been able to look at how it can be prepared in the laboratory. We have been able to look at industrial preparation in this lesson, or the first aspect of chlorine and its compound. We have to look at its physical properties, chemical properties. After that, we have also looked at how chlorine can be tested for when it is present, its uses. We shall continue from lesson 2 at hydrogen chloride as a gas and the hydrochloric acid. And it uses, inshallah, the lesson 2 of this parts of chlorine and its compound. I pray Allah bless our knowledge and give us the understanding. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.